Okay, we're at 14, counting by 3 still, so 14, 15, oh, that's our 5. So we know we'll have to add it. 14 plus 3, so that's 15. 2 past it, carry our 1, so 22. Okay, I got the 2 because 15, that's our 15, 0. 16, 17, I carried by 2. So I have to put 2 down there and carry my 1 over. Okay, and then 22, 23, 24, 25 again, so let's figure it out. 22 plus 3, that's 5, so that's really 0. 1, 3, 30. So in the base 5 place value, 30 is a multiple of 3. And that concludes number 6. Okay, so for problem 7, it says find the base 5 representation for the base 10 fraction 1/2. So we'll have 1/2 equals like 5. The easiest way I find to do this is draw it out. So we know 1/2, half of a pizza. Okay, so if we split this to where there is our 5 sections, our multiples of 5, we cannot get there with 2. So what we'd have to do is count and see if our 1/2 is above 5, because every time it goes above 5, we have to mark it. So 1, 2, that's not above 5. So 1/2 in the base 10 would also be 1/2 in the base 5. Okay, but we can't leave it like that because we know that we have to write a fraction as the number times 5 to the 0, number times 5 to the first, number times 5 to the second, number times 5 to the third, and so on. And as the fraction, since it's on the bottom, it would be that negative number. 0 stays the same. So instead of 5 times 5 to the power 1, it's 5 to the negative power 1, 5 to the negative power 2, 5 to the negative power of 3. So here our numbers, these numbers right here, could not be bigger than 4. Well, if we wrote 1/2 as a decimal, because that's what we're trying to get to, it would be 5/10 in that base 10. Okay, but we can't do 5/10 as the base 5 model. So what we'd have to do is we would have to subtract and find our remainder. So let's do that. So at that 5, just like we had did, that 5 becomes 0, we carry our 1 over. So then we have 1 whole. But 1 times 5 to the 0. 5 times 5, 1. 1 times 1, 1. So 1/2 in the base 5 equals 1 whole. 1/2 in the base 10 equals 1 whole in the base 5. There we go. Problem 8 reads, how much you tell if the number is even or odd in bases 2, 3, 4, 5, 6, 7, 8, 9, and 10. Can you generalize to base n? So we know n is our unknown number. Okay, but first we got to look at the other bases. So let's start with base 2. Okay, so base 2, we know we can't go over the number of 2. So 2 is really 10. So we start with 10, and then 10, 12. Okay, well, we would add another 1. Borrow again is 100. Then I was wrong there, sorry. And then, so we have 100, 2, we'd add a 1 to that tens place, so it's 110. Then we'd have 112, so we'd carry it all the way over to that thousands. And then we wouldn't end, but I'm going to stop with adding that 10 because it's starting back over. 1,002, we'll start back over at the tens place, and then it moved to the thousands place, and then back to the tens place, over and over again in a pattern. Okay, our 3s, 2, we got 2. 4, we can't go above 3, so drop that 1 down. We're 1 above 3, carry that 1 over. 11. Okay, then we have 11. We'd add 2 more. 12, 13. That adds that 0 there. Carried 1 for 20. 20, 22. And we'll stop there. Okay, so 4s, we can't go above 4. So we have 2. 3, 4. Oh, that's at 0. Carry that 1. 10, 12. 12, 13, 14. That's at 0. Carry that 1 over. 22. We'll stop there. Okay, base 6, we can't go, base 5, I'm sorry. We have 2, 4, 5, 6, that's 1 over, carry the 1. 13, 14, 15, 0, carry our 1, so now it's a 2. 22, 24 even. Okay, base 6s, can't go over 6, 2, 4, 6 becomes our 10, 12, 14, 16, carry our 2, so it's 20, 22. Basically, the pattern is once you hit that number, it's a 10 or a 0. If you go over that number, however many you're going over that number, that's at 1's place, and then you carry over again. Okay, so now let's try 7s. 2, 4, 6, 8 is 1 over 7. Carry that 1. 11. 13, 15, 17. We're right on the money. Carry that over. Now it's a 2. Okay, let's do 8s. 2, 4, 6, that 8, 0 over. Right on the money. Carry it over. 12, 14, 16, 18, 0. Carry it over. 9s. 2, 4, 6, 8, 10 is 1 over 9. Carry it over. 13, 15, 17, 19's right on the money for 20. Last one. 10's easy. 10, 20. Oh my goodness. I was thinking about 10s and not 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Easiest one, what we're used to. So some patterns we can see is in every set besides 2, we have these 20. Okay, then we already talked about our pattern of every time it's over, you count how many it's over and then carry it over. Same thing. So 9, 10 was 1 over 9, had a 1 there, carried a 1 over, so it's 11. The other pattern is if it's in a base of an odd number, once it goes over that number, all the numbers are odd. So 3, once it went over 3, we had 11, 20, 22. So, not all the numbers are odd. Proved myself wrong with that one. Okay, but 5, we have 11, 13, 20 again. 7, we have 11, 13, 15, until we get to 20. Let me rephrase that. Until we get to 20, they're odd. So in between their number and 20, they stay odd. There's the pattern. Okay, 2, 4, 6, 8, 9, we went over the numbers. So then 11, 13, 15, 17, 20, we're back to even. Okay. Next problem, number 9. Ask us. I'll go to the page for number 9. In order to use base 16, we need 16 digits. However, we only know 10 digits. 1, 2, 3, 8, and 9. So to represent 10, 11, 12, 13, 14, and 15, in base 16s, we will be using A, B, C, D, E, and F respectively.